Hello. Hi, I'm Greg Allen. I'm the moderator for this session. If you could all just take your seats, we'll get started.
All right, don't get me in any trouble.
So this is the panel on artificial intelligence, automation, and augmentation. I hope that's all what you intended to come for, because that's where you are. I'll start with a few housekeeping items. The first is we'd like to thank the Breakout Room sponsor of this session, which is Noblesse, so thanks very much. Regarding questions from the audience, which I will definitely leave time for at the end, if you can just pass those to the end of your rows, volunteers will come by and collect them. This session is eligible, for those of you who care about this sort of thing, continuing education credits. So if you're interested in obtaining them, please be sure to have your badge scanned at the end of the session by the Summit staff in the back of the room. And an email will be sent out to those scanned after the Summit is over. And finally, just please be aware that media may be present during this breakout session. In fact, I'd be quite surprised if they aren't. So I will now start by introducing our panelists. We have a great group for you today. Starting on my left is Amir Khosrowshahi, who is a PhD and has a PhD in computational neuroscience and is the co-founder of Nirvana. Nirvana was a very hot AI semiconductor startup, but then it was acquired by Intel in 2016. Amir now serves as the CTO and VP of Intel's AI products group, which some very exciting stuff is coming out of. Director Don Meyerriecks is the director of the Science and Technology Organization within the CIA, which is a job exactly as important and exciting as it sounds. Director Meyerriecks has had a very distinguished career spanning both the public and private sector over several decades. Director Mike Bender leads the Laboratory for Analytic Sciences at the National Security Agency. This is a role that puts him in the unique position partnering with the academic and private sectors. And he is on the faculty at Loyola University, but has worked for the NSA his entire career, which is terrific. And then finally, Neil Wiley is the Director for Analysis at the Defense Intelligence Agency, where he leads DIA's all-source analytics analysis efforts across the regional, functional, and S&TI portfolios. He's had a very long and distinguished career in the Defense Intelligence Agency, and prior to that, the US Navy. So please, let's thank and welcome our speakers. So Amir, as the science and technology AI expert on the group, I'd like to start with you and to borrow your expertise. Could you just very briefly explain for us, because we have had automation for many, many decades now, what's different about today's AI systems? How do they work? What is machine learning? And what can they do that's different?
So you give me, as I understand, 1 minute to say this. So it's actually not so complicated. The way I think about the current state of AI is as follows, that we're building systems that can learn from data and can perform inference. So the most basic way of explaining this is you have a corpus of data heights of a population. You learn a model. Potentially it's a Gaussian, and then you perform inference. You can ask the model, hey, what's the mean of this distribution? How tall are males versus females? What are the extremes? And so forth. So we're doing learning and inference on data. That's how I view AI today. And it's part of a larger narrative. There's a lot of hype and excitement around AI, which is really wonderful, and it's really pushing the field forward. But this story of AI that's been in the news in the past 3 or 4 years is actually part of a much larger narrative that is a better way to wrap your head around what's happening, especially when you're working with private sector companies and public sector and startups and so forth, is that we're merging two kinds of thinking, computational thinking and inferential thinking. That we have computer science, we have operating systems, we have databases, we have web servers, we have hardware to support this infrastructure to do these things. And then on the other side, we have statistics. We have distributions of noisy things, and they're unstructured, they're structured, and we're able to build statistical models. And what we're doing today in AI systems that are in deployment are we're merging these two kinds of thinking. So computational thinking and inferential thinking. And this idea is borrowed from a professor at Berkeley, Michael Jordan, just to cite. How was that?
It was great. Could you turn on this microphone? Oh, okay. So that's terrific. I'd like to ask, though, what is the consequence of this merger, as you described it? What can today's AI do that was previously impossible to automate, and why does that matter?
So one of the things that we can do today is that we don't have to hand engineer these systems, that these models, these statistical models, have a high degree of representational power, that they can take very complicated data, images, videos. These are quite high dimensional and complicated things. There's also a corpora of text, and they can learn the structure of this data. They can learn that in images, some regular statistical patterns appear. There's walls, there's edges, there's occlusion, and so forth and so on. The systems can learn by themselves. You don't have to build it into them. And that was what was predominant maybe 10 years or 20 years ago in building AI systems. The systems can learn the structure of the data by themselves.
Great. And Director Meyerriecks, I'd like to turn to you. Why does this change in technology matter for national security?
So please call me Don first if we could go there. To differentiate me from an AI. Let's see. So I think the opportunity that we see in terms of the application, and I like the computational plus inferential, I think that's really interesting, is that it can be a very powerful sidecar to our scarcest resource, which is really good analysts. So we don't look at this as it's going to suddenly make, analytic talent obsolete. It takes our best people and it queues up for them the things that are going to fundamentally impact their judgments. And that's what we provide, is that ability to make best use of the brain power represented by our analytic community so that we can do a better job of representing the options and the likelihoods to national security.
Great. And outside of your organization, how do you more broadly see AI as affecting global security?
Well, okay, so AI all by itself, any technology is both positive and negative, right? So it provides both opportunities as well as attack surfaces that are frightening. So if you think about Internet of Things, right, a garbage can being able to communicate that it's full and the alley near it is empty is perhaps a good thing. If you put that garbage can in a field of fire in a stadium, and it's lying, maybe that's not such a good thing, right? So I think in and of itself, it's neutral. It really depends on the ethics and the kind of the norms that we negotiate on a national basis, on a global basis, and the security. If your security is as good as your weakest link, then we need to think long and hard about that.
Great. And Amir, bringing it back to you. These systems, how rapidly is the state of the art improving? How fast is performance improving, and what does that mean for the next 10 years, the next 20 years of AI?
So this is a really critical question when we work with private sector where this development in this field is the fastest. This is a question that we have to answer is, what can AI do today and what can it not do? And there's a constant misperception of what AI can do today. So if you have an image, you take a picture with your iPhone, you can identify objects in the image fairly well, but the system can't have a semantic understanding of the image. What's going on and what it means is more difficult. Same in natural language processing. You have sentences you can translate from one language to another fairly readily. That's been a somewhat solved problem, but in the mistakes that the machine makes, it's really readily apparent that, again, that the system doesn't have a semantic understanding of what sentence is, grammar is, what the intent is, and what the context is. These are things that are being worked on, and in all the different areas that AI is being applied today, there is this boundary that you have to identify and be very cognizant of, that there are things we can do today, there are things we can't do today that we're working on, and there are things that are very large open questions. So building human-like intelligence is an open question that's potentially a distraction for much of the conversations that are ongoing.
Great, thanks. So Neil and Mike, I'd like to get you in here. What applications of AI are you most excited about for your organization today, given where the technology is? And what are you most excited about that's down the pike in 5 or 10 years?
Would you like to go first?
So I'll give it a go. So I think the application that I find the most exciting and intriguing is the general ability now to turn into a business opportunity that massive data that the world now creates by measuring itself. So by which I mean this, I'm in the all source analysis business, which basically means that however we perform it, We derive judgments through consideration of the the largest amount of potentially relevant information to that problem that we can. We're source agnostic. So right now, under the old manual process whereby an analyst picks up, admires, curates, sits down, and picks up the next piece of information, our throughput is extraordinarily small, and we only really consider a fraction of the potentially relevant information out there. So from a strict intelligence ethics standpoint, it's questionable the extent to which you can really call yourself an all-source analytic agency if you're generating your assessments based on an ever-diminishing proportion of potentially relevant information. So that automated analytics or machine-assisted analytics will allow us then to consider a much larger proportion of the potentially information is ethically satisfying to me. Secondly, it's materially relevant. So everybody's familiar with the old saw that you can get a sense whether the Pentagon's operationally planning by how many pizzas show up in the parking lot. And if you're an intelligence analyst on Mars, you might in fact come to that conclusion unless you are aware of that one small fragment of information that says it's pizza night in policy, in which case your well-crafted assessment turns out not to be right, and it turns out not to be right based on one piece of information that you may or may not have collected, or that if you collected it, you may or may not have considered it. So it's materially relevant that we do this as well. So there'll be dozens and dozens and dozens of algorithms and processes by which individual and different data types can be brought together. I think the holy grail down the road for us will be being able to bring that data together in an environment where you can look at and fuse both classified and publicly available information sort of in one spot, because that's real power, right? Not dealing with it in classified or unclassified stovepipes, but the more information, the more data that you can run in a common environment means that you can squeeze those insights that are only available through the fusion of classified and unclassified holdings.
Well, thank you all for being here. I'm fascinated by this topic and fascinated by the opportunities that it presents. I'm a technologist, but I'm not fascinated purely by the technology that goes on. I'm actually fascinated by the human and AI collaboration that allows us to be able to explore new use cases across domains. Why is that important to you? If you think about the use cases that you may have things that have to deal with precision medicine, smart cities. Maybe you're looking at financial risk, or maybe you're looking at environmental sustainability. All of those things in their independent domains are very important to each one of us in this room and how it relates to our future. But the thing that I really believe is an opportunity for us all is that what you see in that one domain may apply to another domain. It allows us to actually look at data sets and information and be able to start to understand perspectives and insights across domains by leveraging what's available in some of the domains themselves. So I look to the opportunities. The challenges are also going to be a new opportunity in a different way. Because as we've discussed here at the moment, the AI, what we currently see as in AI, is maybe at the beginning of a stage. Maybe we're at the point where maybe in terms of AI and human collaboration, we could think of AI as being sort of an executive, somebody that takes a task and actually defines that task. But now we want to get to that point where we're actually able to get some sort of language understanding of what's going on, some context to where the AI could actually take an action, some understanding that allows us to be able to use these types of technologies to be able to assist us as perhaps co-workers in part and parcel at some point in the future.
Great. And let's frame the same question in a bit of a different way. And this is for any of the panelists. What's the low-hanging fruit to be picked with regards to AI as applied to your missions?
I'll give it a shot, at least as a starting point. So there's a lot of unexamined data that Neil talked about that you can apply machine learning to identify objects of interest in the scene. So for example, video, things like that. We have a ton of work to do as a community in terms of tagging, which is absolutely essential to actually be able to do anything interesting with this stuff from an analytic perspective. So being able to take some of that grunge work and turn it into something that a machine can do with a fairly high accuracy, 80 to 90% accuracy, and then get it, kind of fixed with a human being is a big piece of where we need to start from a community perspective.
So would it be fair to restate what you're saying is the low-hanging fruit are large data sets that we have already collected that nobody's actually analyzing?
Yes.
Great, I think that's quite helpful. So with regards to this technology, I think there is sort of a general understanding, and feel free to disagree, but there's a general understanding that the private sector and academia are really leading the way when it comes to the technological state of the art, which is unfamiliar for some of those in the national security community who have been responsible for so many breakthroughs in other technological domains. I'd be curious to know, do you think, is this understanding correct? And what does it imply, if it is correct or otherwise, for what's the right way to bring AI into the IC?
I don't buy it totally. The reason I don't buy it totally is because with the sort of the emergence and the activities that are taking place in the AI domain, it seems that many individuals become the experts of what's going on. So I think it takes place there. Those individuals then, they may work for companies, corporations, academics, they may actually work even for government. The hard thing is getting everybody sort of to work together in some sort of collaborative fashion to be able to bring their independent capabilities together and put them to bear on a particular problem to try and achieve an outcome. I think it's an individual pursuit at the moment where in big business and academic there's a lot of hype.
So I'll have a bash at this too. So I've certainly heard that characterization before, and as my colleague, I'm not entirely sure that I buy it completely. There is a substantial amount of large data analytics that's done in government and that's done in the intelligence community. In fact, we dealt with some of the original very large data problems 30 or 40 years ago. And we have a number, certainly in DIA and our colleague agencies as well, we have a number of large data analytic efforts ongoing that are fielded now and that generate analytic outcome. So that said, it's not as if I think we are completely inexperienced in this. But I do think it is fair to say that unlike the 60s, where much of the great technological innovation was driven by government funding, driven by the government, it is a great wide world out there, and there are a number of companies known very well to all whose business is in large data analytics. And there's a business model for them. They operate it extremely well, and they deal with things in large data that we do not. So we have a different need for large data. We have different applications for it, but a lot of the broad science behind it is the same. So I think really, to me, the best way to bring this further into our profession is through a very vibrant public partnership with the commercial world. I don't think we don't know how to do this, so let's just chuck it over the fence and hope for the best. Or, no, we can do this without industry. We can't. So this, I think, is absolutely ripe for a very, very deep partnership.
So that's really quite interesting, and I'm curious what you feel about the status of partnerships with commercial industry, and especially sort of non-traditional defense companies, defense and intelligence contracting companies. After the Google pulled out of Project Maven, which was one of the DoD's flagship pilot projects in AI, I think there was a lot of concern about whether or not the national security community was going to be able to attract the right types of talent and the right types of companies. So what is or is not working in terms of the partnerships that we have today between industry and the national security government community?
So I'll start. So there's always been, I'll say, an unevenness in how we partner, and companies are going to make things that make decisions that are in their best interest, in their own best interest. I would say that yes, there have been some very public sorts of backing away. I would also say that we've also had closer partnerships than I've ever seen in my career in other instances. And I would cite the relationship that we have with Amazon and C2S as a great example of us doing things very, very differently in terms of how we partner within the construct of current legislative and governance processes, and it works really, really well. And that our ability to innovate based on those kind of partnerships happens at speeds that approach and in some cases exceed the speed at which business is operating. And we just have to be thoughtful about those and how we craft those partnerships in order to prosecute national security missions.
So, sorry if I could just follow up on that quickly. So in addition to sort of Amazon's raw technical capability, what's special about that partnership from an organizational perspective or from the way that you set it up? What has enabled that to be the success that you say it is?
I think what we did really well, and I will caveat by saying that I did not negotiate any of these contracts, so this is my observation as a fast follower from our CIO, who does a fabulous job of these things. They have learned from us. At the end of the day, we still have ingestion data rates because of the phenomenology and the things that we collect that are world-class that they can learn from. So that makes us a very interesting partner. So I don't know if people are familiar with Eric von Hippel's work about democratization of innovation. We are still really, really interesting in terms of big business partners and the intellectual game that we bring and the problem sets that we bring. We generally are great lead users for them. So I think there's nothing spooky about the relationship with Amazon, right? It's just that we are really good partners in terms of thinking about securing and how you do field forward at scale and things like that, and really challenge them technologically so that they have a better business product that services the needs of the national security community as well.
Great. Mike?
This is an interesting question to me because right now I actually live in our own experiment called the Laboratory for Analytic Sciences. And the challenge is to try and figure out how do you get to people to create. I mean, it's not like you're going to buy yourself out of a problem, and there's a scarcity of resources that we're all dealing with to be able to do that. The interesting thing about it is that there's every single person in this room, there are three things that matter to you. One is you want to do something that's relevant. Two is you want it to be valuable. And three is you want people to be able to use it. Doesn't matter whether you're from industry, academic, or government, whether you're a researcher, a developer, or an analyst. That's what you want to be able to do. What we try to center people on is not trying to figure out that money is the only currency to build this collaboration, because it's not. The collaboration can be built on other currencies. Those currencies can be the intellectual property that you have in a domain. It can be built on the data that you have, because one data source may be much richer to be able to prove and explain an algorithm, to be able to give some sort of transparency to what that algorithm is doing and things like that, that you could evaluate that in another place. I think we're on the verge of a new and different type of collaboration with all the partners that are involved.
So what is the right way to structure an AI program? What's the right way to acquire AI capabilities? Is it infrastructure as a service, software as a service, traditional systems procurement? Is there anything special about AI technology that makes different acquisition methods attractive or unattractive? And Amir, I'd be interested in you bringing in some of your experience working with commercial as well as government customers.
So one of the main things that I like to point out is building an AI system has lots of components, it has lots of engineering, whether it's hardware, interconnects, memory, physical things, physical substrate. That's what Intel is very good at. But it also involves lots of computer science, databases, operating systems, and then you have the machine learning, you have the statistics I mentioned, and then you have different verticals where the domains of application of AI, you need to use different sets of engineering again. So there's a lot to building an AI system besides the core AI itself. In the press, in the media, we hear about my company built a processor for artificial intelligence. I would like to claim that that's the crux of the problem, but it's not. It's all the other stuff that is overwhelming and taxes organizations. Building an AI system is potentially having an interconnect that's really fast so your racks can communicate with each other. And it's very fragmented at this level, at the AI systems level. And that's the main stumbling block. So when you're trying to build an AI system, you have to be mindful that it mostly consists of things that are not specific to AI. And some of this stuff has been around for a while, and it's very difficult engineering. Sometimes it's even open problems, compilers and so forth. These are really complicated things to build well.
Great. And Dawn, correct me if I'm wrong, but I believe that you said the partnership with Amazon is primarily structured as a services acquisition. What works well or does not work well about acquiring AI as a service, or from a services perspective?
Well, so I will say that we use a lot of, right now, open source in terms of, so we are right at the front end, and I characterized earlier in a conversation with Greg and some others that we're really at the front end of the potential of this, right? So I would hate to say that there's a right or a wrong way to contract for this. We do, in fact, buy for evaluation purposes, and places like SVIO, you can actually deliver your capability to the AWS stack that we use so that it's easy to bring it through, and we can evaluate it. We can actually fly before we buy. So I think you're exactly right. There's still a lot of just basic blocking and tackling. There's tagging, there's infrastructure, there's a whole lot of things. And we are using a lot of open source just to evaluate and kind of separate I'll say it, the men from the boys, but the advanced analytics from the actual machine learning capabilities, because there's a lot of snake oil out there, shall we say?
And so the only thing I'd add to that is, and I'm about as technical as this pen. So from my perspective, however we acquire advanced analytics, AI, whatever the solutions we do, it's deeply important to me that we remember who we are and why we do what we do. So in the intelligence analysis business, again, we are in the all-source analysis side of life. So we produce an intelligence product. We don't produce an opinion. We don't produce the op-ed piece in the Post. We don't produce a piece of journalism. We don't produce something else. We produce intelligence. And the intelligence community has learned a lot of lessons, sometimes painfully, about what characterizes an intelligence assessment. What are the hallmarks ethically of an intelligence assessment? And they're laid out in the intelligence community directives. So we have to be clear about the level of confidence we have. We have to be clear about how we arrived at our judgments, what sources were available to us, what we liked and what we didn't like, what assumptions we made, what other frog DNA we stuck into it in order to make it make sense. Clear about alternatives. We're clear about where we ourselves are uncomfortable with the thing we just told our principal. Now, that is true for an intelligence assessment, however that intelligence assessment is generated. It's true today for an intelligence assessment that's done by humans and walked in and delivered by humans. It will be equally true for a machine-generated assessment. Just because a machine generated it does not get us off the hook for the ethical standards required of an intelligence problem. So they have to be explicable to our clients. They have to be explicable to the analysts who they themselves then will use them to source. They have to be explicable. So what matters to me a lot when we look at various solutions, when we work with a partner to acquire them or when we build them ourselves, is that we build those tradecraft standards in from the get-go. It's like building a green building. If you design a building from the ground up to be green, it's not that hard to build a green building. If you build a thing and then try to make it green later, that's really hard. Same thing with an algorithm. If you build it and then try to paint some tradecraft on it, that just doesn't work. So whatever we do and however we do it, we have to remember that we are producing intelligence and not something else.
Great. So the White House Office of Science and Technology Policy released a statement a couple months ago saying that artificial intelligence was the #2 science and technology investment priority for the United States. Second behind #1 was the defense of the nation. So really the top priority from a science and technology perspective. My question is, to the extent that you're able to comment on it, what does the investment landscape in AI look like in your agencies? Is it increasing rapidly? Is it roughly flat? And what types of AI priorities are you investing in to date? I think that's a no comment from all three of you.
No,
correct?
so I talked to this a little bit.
No, we were just seeing who was going to crack first.
No, I think, yeah, so I'm not going to talk about whether it's up, down, or sideways. But I will say that I think I addressed that there's a lot of data tagging, just looking at unexamined data that just needs to get done right now, right? And that we are working hard on that. So I
there's
would
some
say
precursors
that's right.
that you have to establish before you can really start
That's right.
ramping up. Okay.
I think that typically what the question is that it comes in, what are you trying to do? What's the outcome you want to try and get? And then the question of, is AI something that would solve that? That's the first question. And the second question may be, should AI be used to solve that? So let's not jump too far.
So from DIA's perspective, I think we find ourselves largely in the same place that CIA does. We have a substantial effort, and I think that effort will receive more attention in the future rather than less, on using AI, again, in my part of the world, to explore and to acquire those insights available from data at scale that we can't do right now. So again, what we are trying to do is generate the best all-source analysis we can, generate the best foundational intelligence we can. AI is necessary, and large data analysis is necessary for us to do that. So it's something that gets a lot of attention, and I think we'll get more.
And it is an area of emphasis for the DNI, and of course, we're all part of the intelligence community, so it is an emphasis for all of us.
Great. So I have a brilliant friend in the Pentagon who has a line so good I want to repeat it verbatim. AI technology will be of limited utility if we don't also have people who can use it, ideas about how to use it, and training to be good at using it. Which leads me to the question, what are your organizations doing to prepare your workforces for greater utilization of AI?
That's a tough question right off the bat. One depends on what types of AI capabilities are you looking at, and what are you trying to do? Then it's a question of what type of training would be there. To the extent of right now, how it's going, I would say that the capabilities are seen, at least from what I see, are far evolving than where the training is going right now. I don't think that we have enough of the training, but I don't know that we know enough about how to train to be able to use it.
So one of the things I think that the agency did really well, and this was before me, so I can brag on them a little bit, is they started a data science cadre about a decade ago. And that has been huge, because what the commitment was that it would be, nobody owns it, there's a caretaker, so to speak, but it's a real emphasis on bringing in those with current talents and maintaining those talents, and then farming them out into mission space so that they are working on a variety of problems, sitting with our best analysts, either for, leadership intentions in China, or pick whatever your thing is, right? As well as the back office stuff, which is, are we moving the needle on our diversity so that we actually can demonstrate that we have an inclusive environment and represent the population that we're trying to interact with. So it goes the whole way from, the very intelligence-specific questions to are we the right organization? And I talked about one of the things that these folks have brought with them, which is fabulous, is they actually are very meticulous about metrics, about data, so that we actually have business metrics that we can apply that says, is this actually moving the needle on a particular intelligence question or challenge that the director has, so that we can be steely-eyed in terms of, is this experiment working, and is it making, it doesn't mean that we have to get to an answer, but is it making is it making the progress that we expect it to, a la kind of the HOMAR framework, which works kind of irrespective of which domain you're applying it to. So they brought a whole new sensitivity to that and a whole new discipline that I think is really, really useful for us to think about this as we move forward.
So the question always comes up, right, to that old saw, is do you need a different workforce? And it's one I try to dodge all the time because I'm actually not sure it's the right question. But because it comes up all the time, you know, here's my view. So, and it goes back to what our colleague from NSA said, was what do you want to do with it? And what do you want the people to do? So there's various types of technological and data understanding. So, everybody's got one of these. I always wanted to do this in an environment because I'm never in a place where I can. So now I can. Right? Now, I have no idea how this works. None. As far as I'm concerned, you sacrifice a sheep and it happens. But the fact of the matter is, I can use it. Right? The applications are generated in a way that I'm considerably, at least opinions vary on this, but I'm considerably more effective because I have this thing than I was before. So in this case, this has democratized an awful lot of data science, and it has democratized an awful lot of capability. And it may be, for a number of applications, what you need is democratized data science. In other cases, what you may need are people who they themselves can develop those capabilities, develop those things in concert with those people who are simply more democratized. One of the other things that we are finding, we've hired a lot of entry-level people over the last 12 or 18 months. And what we find with this generation is the level of quantitative awareness of arithmetic literacy is much greater than it was for my generation, particularly in areas that you don't intuitively associate with quantitative analytics. So there's a lot of quant out there in a lot of places, and there's a certain amount of generational literacy that shows up now with people. So I'm not really sure it's a question of having to take all your workforce and send them out to the re-education camps in the countryside. I think we can be considerably more nuanced about that, and I think we can do this in such a way that that this becomes approachable, and that you need a very small, or a comparatively small cadre of deep data science specialists, and then a much larger cadre of people who bring grammar, logic, and rhetoric, intellectual passion, critical thinking, the ability to work well with others in a way that's more quantitatively literate than perhaps I am. And I think you will get an awful lot of goodness about that. But my crystal ball is as fogged up as the next guy, so I could be entirely wrong.
Amir, does that resonate with your experience? When customers want to increase their utilization of AI on a specific mission, what do they need to do to set their workforce up for success?
So as we discussed, AI borrows on a lot of technology, and it's hardware, software, domain expertise is really necessary. I hear things that are misconceptions, such as radiologists will be replaced by AI in the near future. That's completely false. A radiologist doesn't just make circles around weird things in images. The task is actually much more difficult than that. So when we're discussing solving AI problems, it has to borrow on a lot of disciplines. And, but the core elements are computer science and statistics. So there are curricula now at places like Berkeley where they're changing the way this stuff is taught, that they're intertwining these things at a very early stage. So if you're a freshman, there's now a data science course where you're taught the basic elements, and it's not theoretical physics, or it's not very advanced. It's pretty tangible and easy to learn. But again, it's this nature of it borrows on a lot of things that is an organizational challenge. Not every person has to know how to build a physical substrate for atoms to make transistors. This is what Intel does. It's basically a bunch of biochemists and lithography tools at some level. And I'm a neuroscientist. I actually don't understand how that works, but I can get along pretty well inside my company and in conversations with people. So I think it's just like any technology, this thing is actually a magical device, and it's potentially much more intractable to me than building something that detects animals and non-animals and images. So it's just like any other technology, borrows in lots of different disciplines, and you have to just be able to wrap your mind around it. And it's a constant challenge for me. It's physical substrate, it's public policy. I'm talking to congressional staffers and people who are moving photons through silicon. So that's part of the challenge. I don't have to understand everything, but I kind of do in some sense at a high level. And that's the biggest challenge that we need to impart on private sector entities that are doing this.
Great. And then I think the public is very concerned, or at least certain elements of the public are concerned about the ethical implications of greater utilization of AI in a national security context. I'd like to get a sense of how your organizations think about the ethical challenges of increasing utilization of AI, and specifically, are there any policies or organizational processes that you're considering or working on or have already implemented to take into account the technological differences?
Okay, I got the short straw on that one. Yeah. So I guess I would make 2 points. First off, there is legislation, there is law, and there is policy that governs what it is, in fact, legal for the intelligence community to do. And as far as I am aware, none of that legislation or policy exempts this. So what is legal for us to do and what is allowed by policy for us to do as intelligence agencies, we must conform to in this environment. So that means when you deal with things like personal information or U.S. persons data or something, there are protections and requirements that have to be maintained. And that will have to be maintained no matter what environment we do that. So yeah, we don't get off the hook for that. And second one is, and I've already talked about this a little bit, you don't get off the hook for your ICD compliance and your tradecraft compliance through this either. And so we have a process inside DIA where we look at the tradecraft compliance aspect of any automated system we use that ultimately has the potential to release something into the intelligence record. So we'd have to do this for a human-generated piece of intelligence. We do the same thing in the case of machine-assisted analytics. And again, that has to make the same tradecraft standard. It has to meet the same tradecraft standards, and it has to be deconstructible from the analyst's perspective. So we do have some policy, they're mine, in place to do that. And in fact, kind of the way it's almost, to me, some of the fielding these things is almost, it's almost similar to the pharmaceuticals industry, where, you know, when you put a drug out, right, you have to be sure that, or at least you have to be tolerably confident that the drug performs as advertised and that you understand what effect it's going to have and that you also understand what side effects it's going to have. So that the physicians can then prescribe this with confidence and the public can consume it with confidence. And you go through, you know, a process of clinical trials to determine that, in fact, your understanding of that is as accurate as it can be. And then once you let it loose, then you do a whole bunch of post-trials monitoring to make sure that actually what you thought on small scale actually works on big scale. So to me, there's that ethical responsibility that you have for any piece of intelligence analysis, but particularly this stuff because it's produced somewhat differently.
Great. So I'm now going to turn to questions that we got from the audience. I think one of the themes that I'm getting from these questions is literally, I think you could summarize 3 of these as, is my specific job going to be automated? So we'll start with...
Where's that radiologist?
So maybe I'll just read them all, and you can respond how you see fit. And Dawn, you're going to draw the short straw here. So first, is D&I Coates priority for enhanced economic intelligence a good candidate for AI and machine learning? Second, Does the panel see AI as being immediately useful in complex fields involving psychological reasoning, i.e. prediction of behavior? And then, well, let's start with those two. And maybe if you could just sort of broadly sort of give some guidance to the community. Should they be thinking about this? Should they be thinking, is my job going to be automated? And what do they do if the answer is maybe or yes?
Well, okay, so I am not going to represent the entire community here. My slice that I've worked with and understand of it. No, you shouldn't be worried about this unless you are, a drudge someplace that, is alphabetizing things in the library, which I don't think anybody here is. No, you're not going to be replaced by an AI. I think that that's way overhyped. And as I talked about, and we've all talked about, what we see as an advantage to using the gray matter represented in people like Neil to best advantage, right? And there are a lot of grunt things. One example is looking for, cameras in scenes. One could imagine why we might be interested in things like that. There's no reason that a human being should look at, videos and photos and spend their 8 hours. Just from a behavioral mechanics perspective, you can't actually spend that much time looking for something. The performance will start to decay. So that's the kinds of things that we're looking at, so that when we actually present something that's already, I'll say, curated to a high degree to an analyst in order to decide what to do with that information and whether they choose. And actually we learn by them telling us, no, you did a really poor job, these 3 things you completely missed. That's very useful to us. To go back to the economic intelligence, yes, it's really important that we understand what's going on, not just from an ability to inform national security priorities, but also to understand what's real versus what's Meyerriecks in this whole space. I will say that I am impressed by the coverage of what China says they are doing with respect to application of machine learning to their, kind of people scores. It stretches credulity, in my opinion, that they are nearly as good as they say they are, right? So understanding what's actually at the basis of the technology and what's actually possible in other than very constrained conditions also helps us understand what the real threat is that we are facing, and that's absolutely essential for us to stay relevant as we move forward, because the other thing that we don't want to do is play kiddie soccer in areas where there's a lot of hype, but not a lot of actual motion.
Okay, great. Then this is a specific question. I suspect there's somebody's product involved in this question, but are there efforts to move AI closer to the collection sensor front end? So I think what this question is getting at is a lot of AI processing is currently done in the cloud on server farms. And the question is, as the hardware technology gets better, might this have an impact for the sort of at the sensor level of processing? And Amir, I suspect this is something you're going to be interested in.
Yes, so for example, Intel produces processors that are specialized for drones. If you put a Xeon data center processor into a drone, the drone will crash. It will use too much power. It doesn't have the special computational abilities that a drone processor does. So there is a lot of focus on the full end-to-end edge to data center integration, and there's pieces of silicon and software and other kinds of hardware that is involved in each part. But some of the things we're seeing is lower power processors in edge devices that are kind of like little brains. In a data center, you might have a full rack of homogeneous processors, CPUs, and then specialized hardware for AI. At the edge, you see this shrinking of this data center into a little chip, which has a computer vision sensor, it has a natural language processing sensor, it has general compute, it has lots of little things that are kind of like a compressed little brain, like an insect would have. And that's because of the stringent requirements at the edge of power utilization and just latency savings of various kinds. The metrics for success at the edge are quite different than in the data center. So there is a lot of focus on this, as well as so inference, being able to see things and classify is one thing, but now we're moving towards other things such as personalization and also privacy is another concern. If you have an edge device, can you make that machine learning that happens on the device private from the data center?
Great. Anybody else want to follow up? Okay. This is bringing into the more international security domain. How is China's military using AI, and should we be concerned?
Yeah.
Using, I suppose, open source intelligence only in this analysis.
Yeah. Well, I think it's clear from publicly available reporting and what China itself says that they consider AI as AI and data-enabled analytics, data-enabled command and control, and data-enabled decision-making as key to retaining speed and initiative in warfare. And particularly when you connect that with autonomous and semi-autonomous systems, there is certainly the potential there for that to be significant. So we, as part of our daily professional business, we maintain due diligence in looking at what any country has, what any country's potential military developments are. So should you be concerned? So I get paid to be concerned about that sort of thing. And that's what most of our mission is.
Great. So this question is a bit lengthy, but I'll read it as it is. In a recent JFQ article, Courtney Weinbaum of RAND and General John Shanahan of DoD's Project Maven state, quote, "The IC's greatest potential asymmetric strengths remain its ability to make sense of data quickly. Will the United States and its adversaries slow down their machines to the speed of human thought to maintain a human in the loop? Or will each country pursue AI to its fullest potential," end quote, in order to process information quickly on the battlefield? So I think the question that's it's finally driving towards is, what is the right balance between slower human analysis and faster machine automation?
So I think I'll start and then encourage my fellow panelists to jump in on this. I think we've demonstrated that, I'll say not AI, ML, but advanced analytics in the past, that we are very comfortable kind of closing that last tactical in very, very constrained context and very, very constrained problem situations, right? We've had precision-guided munitions for a long time. At some level, you could say that that's advanced analytics, and we've been doing that for years and years and years, 50, 60 years. So I think there's a whole spectrum here. I think the question is almost a false dichotomy of like you have to pick one or the other. There's a whole spectrum of timeliness, resilience, lethality, kind of the risk that you have to think about in order to answer the question, and it would be naive to say that you're not going to have specific answers based on the, I think I got it exactly right. Domain expertise is essential, and part of our domain expertise is knowing how to do that risk gain analysis, and where it makes sense, where we can, basically take our hands off the trigger. We've got worked examples of that. We know how to do that, and where we have to be much more circumspect because we do have these analytic standards that are not going to be relaxed in the face of any amount of technology that we throw at a problem set.
Yeah, I think also to the question you ask, and this is certainly outside of my competence, but there's a question of from a policy decision maker's ethical perspective, right? To what point are we comfortable not having human accountability in warfighting decisions, right? And again, that's not an intelligence question. That's a national leadership question. But the extent to which ultimately, the nation or the leadership makes the determination as to what that extent is, I think will drive what we are then required to produce.
Did you want to jump in, Mike?
Well, I think it's going to depend on what is practically possible given any particular situation that you're looking for. I can think of some cases where, in order to be able to just give you a picture of working with somebody to be able to do this. One time I'm standing over their desk, and they have a lot of Post-its on their desk, and I'm asking, so why do you have the Post-its on your desk? Is that actually how you're doing your analysis? And they're like, no, that's not how I do my analysis. It's how I give myself a chance to think, to be able to understand what that is. In the context of that, I think that what we want to try and be able to do is we want to try and be able to provide capabilities that augment analysts to be able to do that as quickly as they possibly can, not instead of them or things like that. But there are some things that where maybe we need a speed bump or something like that. The question that you might ask is, why do you need that speed bump? And is there a way to be able to alleviate that speed bump realistically in a practical situation to be able to get where you want to go?
So if I think I understand you correctly, you're saying it sort of varies heavily on an application by application, mission by mission, technology by technology basis.
Sure.
And understanding that nuance is sort of critical to the expertise you all bring.
Sure. Think about it in terms of cyber capabilities or something like that, where the decision support has to come in fractions of seconds and things like that. You don't want to necessarily have a machine just firing it back like this. At the same time, you may not have enough time to actually, let's think about it, let's do that. By that time, you're bringing dry ice. It's sort of to try and figure out, how do I meld both the human, what humans do well, with what machines do well, to be able to center on being able to achieve that decision support that you need to make that decision.
So these questions that I'm encountering now can be sort of presented in a straw man version. So I'm going to try and give them the most charitable framing that I can think of. With machine learning AI, we have just in the past 5 years watched a lot of our intuitive understanding of what can and cannot be automated breakdown. We used to say imagery analysis really requires a human brain. Suddenly, there are certain types of imagery analysis that computers are quite good at when you incorporate modern machine learning techniques. Which brings us to the question of what current barriers of the limitations of AI systems should we expect to be breaking down in the future, and what will it mean if we can do that? Which gets to the question, as the audience member asked it, how far are we from cognitive AI, which is sort of AI with reasoning and planning capabilities similar to that of a human?
I'll be retired.
Amir,
It depends on the human, which would be my favorite.
I can make a go of this.
Yeah, it outperforms me now all over the place.
So I've been in this field since 2005, where it experienced its renaissance. So neural networks and AI. I entered the field as a student in around 2005, and I was very skeptical of a lot of the developments at the time that became formative for what is successful today. So I had a lot of learnings and resisting, and then seeing that these things are actually working, and they're working quite well. Some of the things you mentioned, if you look at an image, to be able to recognize what's in an image, that's actually a really hard problem. To understand some of the semantics of what's going on in the image is actually currently beyond the abilities of AI, and I think that will be addressed in the near future. Again, machine translation has huge applications, lots of benefits in the commercial, private sector, as I'm sure in the intelligence community. That problem has been solved largely to some extent, but again, the machine doesn't understand what it's doing. It's taking corpora of one language and has another corpora in another language, whether it's a DUN or another setting, and it's doing it in some brute force fashion. So what's nice is that we have performance that's relevant to you. We have enough success that in some very relevant situations, such as image analysis and text, we're outperforming humans. However, there's quite a distance from that performance to the human level understanding of these, whatever it is, images, corpora, whatever domain. So the answer to the question is actually we're quite far off. And I was a neuroscientist before I entered this domain. We don't even have a good understanding of humans. We hear about bias, transparency, inherent bias, and things like that. Humans are very unexplainable. They're very far from transparent. Maybe transparency is actually bad. In game theory, you can show that in a multi-agent tribal society, that transparency can actually cause the end of the society. These are very difficult questions on both sides, the technology that's developing and the brain part of it. So I think it's actually quite far off, but there's going to be a huge amount of innovation and disruption and change in this area.
So would it be fair to say that there's a lot of capabilities and things that AI cannot do right now, but we should expect continued progress, right? We should expect these barriers to be broken down, but there's this level of humanness that you expect to endure for quite some time.
So if I can just answer that quickly. So there's two kinds. One is your voice recognition system, your house, your chatbot thing, that's Alexa or Siri. These things will gradually improve in time. Your cars will gradually improve in having more safety features that are AI. But there are significant barriers that are 10 to 15, 20 years out. Having systems that can reason and have the intelligence at the level of a human, that's quite far off, and it's actually undefined what that actually is. There are entities like Google DeepMind has a Go game playing engine. It was a remarkable, outstanding achievement, but the game of Go, putting black and white pieces onto a board, is potentially even simpler than just me lifting up this bottle. Is a very difficult task to get a robot to do. To get a robot to get out of a car and open a door is almost an unsolved problem, but we can solve the game of Go. We can translate from one language to the next. Some problems in AI seem to be really easy, and we're discovering what is easy and what is not, and some problems are just hard, and the real hard problems of AI are still hard.
Can I just pull a thread on that? I think that one of the interesting things that we're seeing, and I'll pick on imagery analysis because you raised it, and I think it's a great example. It turns out that the machines are much better at detecting things that humans are not. So when you put those two things together, at least that's been our experience so far, right? And I don't know if anybody's seen NVIDIA, the demonstration where they generate the superstars, that they actually aggregate the features of a bunch of, Kevin Bacon and Angelina Jolie or whatever. They actually generate people that look like, there's the human being says, oh yeah, that looks like so-and-so. The machine knows very well that it is not, based on, so it's actually, the promise is that those things can be very complementary and that we can detect changes with the machine that we wouldn't see from a human perspective and vice versa, and thus cue it up to smart people to actually make sense of. I think AR is another great example that the ability to project into space something that is credible as you or as a human being is amazing, right? So there are opportunities there from a mission rehearsal perspective that we can fool our senses. At the same time, the implications for cognitive psychology and neuroscience in terms of figuring out how your brain works and how your eyes do that hack so that they actually only process, a small percentage but are very good at reconciling where you are, right, is another opportunity that we haven't only begun to scratch the surface on.
Great. One last question from the audience, and this goes for the entire panel. What is the most important single AI initiative at your organization, and what deliverable has it produced? And I'm sure this is like a picking among your children kind of challenge, but what is the single most important or exciting initiative at your organization using AI? Amir, you look ready to answer.
Okay. So what's really remarkable is that we've had this long history of AI. AI as a field started in the 1930s with John von Neumann and Alan Turing, who were the first artificial intelligence researchers. They were also the first people to build computers. And the model that John von Neumann described the first computer in 1940s became the von Neumann computer. That architecture has been incredibly successful, and Intel has benefited, and you have benefited by buying these CPUs. And what's really remarkable today is that Intel is building neural network processors. And that's a significant change, and it's at a really critical juncture where we've described there's lots of data, and the data is increasing in some really frightening way, and the compute is potentially slowing down. So I would argue what's really exciting about what we're doing is that we're providing the compute to also move alongside that growth in data. And this compute is wildly different than what has existed for the past almost 100 years.
Great.
Well, I can't speak for the agency, but I can speak for the lab. It's been pretty interesting recently because a lot of the industry, academic, and government people are very interested in applying any variety of AI technologies. So as a result, we've had a fair amount of work in things that have done with natural language processing, neural nets, some distributed AI, and a few things that have to deal with multi-agent systems and agent-based modeling. The interesting thing of why it's a little bit fascinating to me at this point is that people are actually trying to apply it against use cases beyond the domain of just national security. So we're involved with folks that are doing things for everything from medical diagnoses and precision medicine to environmental studies and things like that, in addition to those things being able to be applied to our nation's security problems.
Yeah, we have a lot of interesting stuff going on too, but I think the one that I'm most excited about right now is we have a number of very technical analytic skills that are, I'll say, signal processing based. And so we've started with them and put the data scientist side saddle with them so that they also have enough of a technological background that they can help do an assessment of the validity of the AI as it's applied. And what we've discovered is that in certain cases, we are making much better use of our national technical means, our space assets, because we're actually tipping and queuing them in an automatic fashion. So we're getting the shot that we need to do a confirmation or a verification, as opposed to taking the same pictures based on a standing deck every time we fly over, pick your favorite subject of collection. And we've seen huge returns on that already in terms of better utilization of very expensive assets, those being the human, who has the signals analysis expertise, and the NTM, which is very expensive but very, very good at what it's asked to do for the national security mission.
So we have a lot of efforts ongoing. I think if I had to pick amongst my children, one of the major missions of the Defense Intelligence Agency is foundational military intelligence, which is that understanding of foreign militaries' structure, organization, equipment, characteristics and performance of weapons, platforms, and sensors, supporting civil and military infrastructure and of the operating environment. That's basically, if you're a military planner, you kind of need to know that if you're going to go off and plan some military operation from a contingency or plan. So the quality of military planning at the outset, at least, is directly related to the quality of that foundational understanding of the operating environment, the adversary. So we have a number of large data efforts aimed at more thoroughly describing the operating environment and the infrastructure in a place where we may be required at some point to operate. And improving that directly improves the sophistication, precision, and agility of military planning. And that's been particularly fruitful, and we hope definitely to continue and pivot off that.
Did you want to?
No.
Okay.
It's just playing with the microphone.
Oh. So that's all the questions we have from the audience. We've talked a lot about why the existing workforce should feel confident about their enduring relevance even as these technologies get more capable. I want to ask about the flip side, right, which is acquiring the AI talent that you need. A New York Times article said that it is entirely routine for a new computer science PhD to be paid $500,000 as an entry-level job. That's quite a bit higher than most folks in the intelligence community make. So how is the intelligence community going to be able to acquire the talent that it needs, and what does it mean if there is a significant shortfall?
So I'll start. I think this is where thinking about how we team differently it's absolutely essential to our future. For example, we've run a summer symposium for the last 2 years with 24 universities where the technical topic was AI and leveraging the work that's being done in these universities directly into our understanding of what products and services we can and should be considering for the future. The other thing that I'll say, and I know this sounds like a cliche, but I've been in and out of government, and many of us have been or could be. At the end of the day, an earnings call doesn't give me the same visceral gratification as knowing that I made a difference in the national security mission. And so we very often, great, go make your money, we're doing externships, all of those things. People want to do the mission that we have available, and they don't have to do it on a pittance. It's something that you can actually live on. Many of us are testaments to that, and it is a huge difference than the quarterly earnings call.
So I want to push back on your answer.
Okay.
And what I noticed in your answer was a lack of radicalism. And I was recently in China at an international relations conference where there were some Chinese government officials who described the AlphaGo experiment as a Sputnik moment for them, meaning that they recognized that this technology was part of the foundation of future global power, and that they needed to radically increase their investment in it, and they needed to completely change their education system. Most people forget that in addition to creating NASA, Sputnik also caused us to pass a National Security Education Act, which radically increased the production of engineers and scientists from both high school and universities. China has literally done the exact same thing. They just passed an education law. They cited AI as the reason. And so the answer that I heard is that, well, people care about the mission, right? But that's quite different from we're going to produce tens of thousands of more AI experts in the service of the country, which seems to be the Chinese approach. So is something more radical needed? An ROTC type model, an increase in education, graduates quotas. Please feel free to disagree, but.
So I think clearly, if you can make $500,000, there's a reason for that as a brand new PhD, and it's not just because you're smart, right? That says that the market has a lot more capacity that it could accept, right? I think I think this is a national question that we should discuss, and it's much broader than the community that's represented here. We should obviously be an active voice in that, but I think you're at the studies that I've read in terms of, for example, gender diversity. In less developed countries, women will very often go into science and engineering because they know that they can have a successful career there. In our country, women tend to be more communicative. They can do fine in math, but they'll end up being attorneys or doctors as opposed to science and engineers. So I think there's a much broader question that you're poking at in terms of how we incent the STEM writ large, right? That we should be a part of the conversation. Certainly not the only ones responsible for that conversation.
Yeah, so let me frame, oh, sorry, please go ahead.
Well, no. So the short answer to your question is I don't know. But the question, I mean, thinking through this, right, would be, okay, so here you have your hypothetical $500,000 a year PhD in computer science. The question to me is, okay, what then would we wish this person to do, right? So I suspect, and again, I'm just looking at things from the analysis side, I probably don't need that guy in the analytic world, but I probably do need that guy somewhere, or that collection of skills in some place that builds things that we would then have to build. On the other hand, if through partnering with industry, then that the industry partner provides those skills rather than having to bring, because so we bring a person on as a government civil servant right now. That's a 20 or 30 year commitment under the current, or at least it's a 20 or 30 year prospect under the current process. Now, it would be nice to have better flow between the public and private sectors, I think, in this. That would be, I think, useful on a lot of people's cases. But my understanding, at least, with technology and industry is actually they cycle through people fairly quickly. The government model for the civil service actually doesn't do that. So I think it's a question of horses for courses. There's probably a role for this person, but we'd have to be very clear about what it is, and then what role you'd have for people who are simply more quantitatively literate. So, can you get that same amount of quantitative literacy out of an astronomer, right, who doesn't make $500,000 a year but has an awful lot of quant? So, there's a bunch of different ways around this problem.
Yeah. Mike, we're basically out of time, so if you have the last word.
All right. I'm going to try to be quick. I have a couple of different perspectives on this for your consideration. One is everybody in this room has a personal and professional goals that you want to be able to achieve. The government and industry, academic, they have their goals they want to achieve. We want to try and get those goals together to be able to do that. However we're able to do that. People want to be able to collaborate. What drives them together is doing something that is relevant, that has value, and people can actually use. I don't have to be able to worry about the discussion of whether, am I going to buy a $500,000 AI or ML person or things like that, because that doesn't come into my calculus. My calculus comes into what are they going to do?
Right.
And if you work for one of those companies and are able to do that, that is absolutely great. The market will demand how long those salaries are sustained. You'll probably have to renegotiate your salary, but you won't renegotiate the relevance, the commitment that you have to be able to work on a problem. And my role is to try to figure out, how do I change that value proposition for you to encourage you to take on my challenges, or me to allow me to be a part of the challenges that you're going to work?
Great. I'll end by saying Eric Schmidt, the former CEO of Google, was the keynote speaker at the Center for a New American Securities Conference, the think tank that I work at. And I asked him if those salaries were justified, and he pointed to Google's acquisition of DeepMind, which was $400 million for, I think an employee base of less than 100. And I said, was $400 million worth it? Is $500,000 worth it? And he said, DeepMind's acquisition paid for itself on the first project we had them work on, which was data center energy efficiency. Literally the first thing they did in less than a year, and it paid back the cost of the acquisition. So I think this is a technology that really is making a difference in moving the needle. And that's why it's so exciting that the panelists show how the intelligence community is taking this seriously and working hard to get it done. So please, let's thank our panelists.